For naming acids, I gave you a mnemonics that is included in the video, Tyler DeWitt's video, okay? And I'm sharing also with you this chart. This chart is a key, okay? A key that you could follow for naming acids. First of all, you need to identify that you have an acid. The best way to identify an acid is because it begins with hydrogen. That is the main characteristic of any acid, okay? Then, acids could be divided in two different categories. Acids that contain oxygen and acids that do not, okay? So, one kind of acid has oxygen, but the other doesn't. Angie, please turn the camera on. Okay, so take a look. Here the chart tells you what to do in case that the anion does not contain oxygen. Take a look closer. We're going to focus on this part. Does not contain oxygen. So what to do in the case that an acid doesn't have oxygen? First, we need to use the prefix hydro and the suffix "ic", and then the word acid. For example, an acid without oxygen. HF. How will you name it? Following these rules. The way to name it will be the prefix hydro, the suffix "ic", and then the word acid. Now, what are we going to write between hydro and "ic"?
Fluoric.
Fluor, okay? So the name will be hydrofluoric acid. Wait a second, please. Now it looks better. Okay, remember that this talks about the anion. The anion is that part of the acid that is not hydrogen, okay? So the anion in this acid is F, and this F, the anion's name is fluoride. Now you can also use the mnemonics for ITE, that is the first mnemonics that says, my right has hydraulics. You can, as I told you, you can follow the chart or you can follow the mnemonics. The first mnemonic says, my right has hydraulics. In this case, it refers to the anion. If the anion ends in IDE, just like in fluoride, you need to include the prefix hydro and the suffix "ic". As you can see, both ways work very nice. Okay. Now, I suggest to use the mnemonics because you can memorize it easily. It's easier, a lot easier to memorize 3 sentences than a full chart. So I totally recommend the mnemonics, but in case that you need to use the chart, there you have it. Now, another kind of acid that we have are those acids which anions contain oxygen. So these kind of acids have a different procedure. So what we need to do is we need to check the ending of the anion, and then we need to see if it ends in "ite" or if it ends in "ate". In the case that it ends in "ate", the procedure will be to change the suffix by "ic acid". If it ends in "ite", the procedure will be change the suffix by "ose acid". So take a look to this example. I'm gonna write two acids, okay, and we're going to name them. Okay, so we have two acids. We need to check the anion. I told you the anion is the part of the acid that is not hydrogen, okay? So we're going to focus on the anion. What is this anion? What is this anion? If you don't know what the name of the anion is, go to the tables I gave you, okay? The one of the polyatomic ions, and look for it. Which one is it?
It is
Which one?
permanganate.
It is permanganate. It is right here in case that you missed it. It is permanganate, okay? So we go back to the acid, and now we know that this anion name is permanganate. And we need to see the ending, just the ending. Focus just on the ending. The ending of permanganate is ATE. So the procedure that we need to follow is the one that indicates ATE. ATE says that I need to replace the ending by ic acid. ATE by ic acid. So I'm going to change ATE by ic acid. So the name in the end is going to be permanganic. Permanganic acid. Now, take a look to the second acid. We're gonna focus just on the anion. The anion is the rest of the acid without a hydrogen. What is the name of that anion? What is the name of this anion? Exactly, Kenneth. Thank you. Dichromate. So we see just the ending. The ending, you recognize the ending as ATE. So again, we need to follow this process right here. The one that says ATE. And we're going to replace the suffix or the end by ic acid. So the name of this one is gonna be, instead of ATE, is ic acid. And the name will be dichromic acid. Just like that. Dichromic acid. Now, the acids have also the possibility that they end up with the anion ITE. So let's try two more examples. Okay, here, the anion is ClO. What is the name of this anion?
Hypochlorite.
Hypochlorite. Again, we check the ending. The ending is ITE. So I go to my chart and I look for ITE and I follow the procedure. It says that I need to change the end by O's acid. Okay? So that's exactly what I'm doing. I'm changing ITE by O's acid. So the final name is going to be hypochlorous acid. You can also use the mnemonics. The mnemonics for O's is the third mnemonics that says Sprite is delicious. Okay? So when the anion ends in ITE, then you will replace it by O's. This is the mnemonics for ITE, okay? Sprite is delicious. So we can apply the same concept to the following example. What is this anion's name?
Phosphite.
Phosphide. But here you need to be careful because phosphorus and sulfur are the elements that have special roots in acids. Remember this, okay? So let's see. What are the special roots for acids? We have other special roots, but for acids it's quite different. So for acid, we have these special roots. We have the one for phosphorus. The root is going to be phosphor, okay? And the special root for sulfur is the entire sulfur, okay, like that. So here, because we're talking about phosphite and phosphite has phosphorus, we're going to use the special root for phosphorus, that is phosphor, okay? Now, see the ending? The ending is ITE. ITE, Sprite is delicious. You're going to replace it by O's and of course the word acid. But remember the special root. Remember the special root. The special root for phosphorus is phosphor, and then I use the mnemonics. Sprite is delicious, so it is phosphorous, and I of course will include the word acid. So it doesn't matter what path you choose in the end, whether you use the chart or the mnemonics, the naming part needs to be correct. But you need to be careful with phosphor, okay? You need to be careful here with phosphor, well, with phosphorus and sulfur, because the two of them have special roots for acids, okay? Remember, these are for acids. For other kind of elements, of compounds, sorry, it's gonna be different. Now, take a look here to this activity. This activity, the instruction is, in which of the following is the formula correct for the name given? There are many formulas over there, but because we are reviewing acids, that's the procedure that we're gonna be doing, okay? We're gonna be reviewing just the acids. So we're gonna focus only on the acids. As you can see, the first acid that appears in this activity is the number 6, which says hypochlorous acid and is giving us a formula. We need to indicate if it is correct or not. So take a look to this. To know if it is correct, I need to see always the anion. The anion for this acid is ClO. This is an L, okay? So it is ClO. What is the name of that anion?
Hypochlorite.
This is the anion hypochlorite. So let's see if the name is written correctly. It ends in ITE, so it needs to be changed to O's acid. Now let's see if the name provided matches the one that we obtained. Hypochlorous acid equals hypochlorous acid. So we say, yes, it was correct. So this name is okay. You can write that it's correct or just the check. Remember to always include the charges because sometimes the anion might look good, but the charge is not. For example, I'm gonna do this extra example. Take a look. What is the name of this acid?
Phosphate.
It is phosphate. So you apply the rule, you change the ATE by ic acid. Remember that phosphorus has the special root, so the name apparently is going to be phosphoric acid. But let me tell you a story. This one is incorrect. Why is this incorrect? Why is this incorrect? Take a look. You said it is phosphate. Remember what phosphate is. Phosphate is a polyatomic ion that has this chemical formula. It is PO4, but it has a charge of -3. That means that when you combine it with an acid, you're going to put the hydrogen, and this 3 is going to be crisscrossed. So the formula for phosphoric acid is H3PO4. So the name phosphoric acid is incorrect for this one, but will be correct for this formula. See the point? It's not just seeing the anion. Always check that the charge is being crisscrossed. But that was an extra example, okay? Let's see if we have more acids. The next acid that we have in our list is the number 9. It says sulfurous acid. Is the name correct? SO3. What is the name of SO3?
Sulfite.
Sulfite. Okay? And the ion sulfite has a charge of -2. So let's see. Is this name correct? Remember what the rule says. Replace ITE. The Sprite is delicious, so you will replace it by O's acid. Remember that sulfur has a special root, so the name is not going to be sulfurous acid. The name will be changed to sulfurous acid. O's and acid, okay? Remember that this is the special root. So, after this, can we say the answer is correct, yes or no?
Yes.
Yes.
Yes, it is correct. Also, the subscript is correct, okay? So, everything is good about it, so we can say that yes, the name is correct in this one. Now, the next acid that we have, you don't see it here, but it's right there, okay? The next acid is this one. Is the name correct? CO3, what is it?
Carbonate.
This is carbonate. So is the name correct? Is the name correct? Is the formula correct?
Yes.
Yes.
Yes. The name and formula both are correct. Okay? So we say that yes, it is correct. And then in the last part, we have this acid. Let's see if it is correct. What is the name of PO3?
Phosphite.
PO3 is phosphite and the charge is -3. So the rule says that you need to replace ITE. Sprite is delicious. So by the ending O's acid. Is the name correct? Remember that this is the special root. The special root. Remember, this phosphor is the special root. And then O's and acid are part of the rule. Okay? So is the name correct?
No.
Is not correct. So this one right here is incorrect. That's not the way it is being named. Okay? The name should be phosphorus acid. So Let's see how many are we today. I'm gonna take a picture for those who are here because it seems like someone left. Okay. Now, let's take a look. We're gonna do an activity. Okay, we're gonna do an activity. Try to participate, the most of you. I know that you're familiar with this website because I share it with you. So we're gonna do 25 exercises, or the one that we can. And I will be evaluating names and formulas. The topic is just acids. And I will choose the multiple choice. Okay? So I'm gonna do the first 5 and then you will participate one by one with the rest. Let's start. Okay, the first one says perchloric acid. Because it ends in ick, I ate something icky. Okay, so it means that my anion will be perchlorate. Okay, and perchlorate is this ion. So the formula for this name is going to be HClO4. Then I see my next compound. It begins with hydro, ends with ick, but just because it begins with hydro, I know that it doesn't have oxygen. So I don't need to analyze anymore. It doesn't have oxygen, so I'm going to choose the one that does not have oxygen. And as you can see, the second element is Br, which is bromine. And bromine matches the root that is between hydro and ick. Remember, my right has hydraulics. This is bromide ion. The next acid is SiO3. SiO3 is known as, it is in the tables that I gave you, and it is known as silicate. Silicate. So I'm going to get rid of I'm gonna write it here. Okay. Silicate. So I will get rid of ATE and I will replace it by ick. In total, this is gonna give me just silicic acid. Okay, silicic acid. Now the next acid says nitrous acid. Ose. Ose. Sprite is delicious. So that means that this anion will end in ITE. So it will be nitrite. And nitrite is NO2. So this will be my acid. Then this last one says sulfurous acid. Sulfurous acid. It ends in ose. Sprite is delicious. So it means that this is the ion sulfite. And the ion sulfite is this one. Because this one is sulfate. Sulfite, sulfate. Remember, Sprite, sulfite. That would be the right way to name it. Now I'm going to mention your names according to the position that it appeared in my picture, okay? And that's the order that you will follow to participate. I know that not all of you will participate, but that's why we do it. Angie Fabiana. Angie Fabiana, which one would you choose for the number 6? Arsenic acid.
H3ASO4.
Exactly, because this is arsenate. So you replace the ATE by IC, arsenic acid. The next student that appears in my picture is Kimberly. Kimberly, which one would you choose for hydrochloric acid?
HCl.
HCl, okay? Remember, hydro means no oxygen. And the only option that does not have oxygen is the last one, okay? HCl. Thank you. Natalia, sorry, I'm blind. That's so embarrassing. Natalia, can you please tell me which one would you choose for hydrofluoric acid?
HF.
HF. That is correct. Thank you, Natalia. Dulce Cuello, can you please tell me which one would you choose for phosphorus acid? Phosphorus acid.
H3PO3.
That is correct. Thank you, Dulce. Then the next student that is in my list is Valeria Oliva. Valeria, can you tell me which one would you choose for carbonic acid?
H2CO3.
Thank you, Valeria. Karen, would you tell me which one would you choose for HNO3?
Yes, let me find it in the list.
I'm sorry, can you repeat?
Let me find it in the list. Nitric acid.
Nitric acid. Let's see who's after Urquía, Dulce Urquía. Dulce Urquía. Can you please tell me which one would you choose for phosphoric acid?
Yes, H3PO4.
That is correct. Thank you, Dulce. Sofía Martinez. Can you please tell me which one would you choose for